about the hyperbolas. So remember, hyperbolas are like your two parabolas that point away from each other, okay? If they are horizontal, meaning they open side to side, then it is the x that comes first. So if you think about it, these like kind of make that x that way. This would be an x minus h squared over a squared minus y minus k squared over b squared equals 1. This time, what's important is a is first, okay? That's true for both of the hyperbolas. A is first, not biggest anymore. Then for your vertical hyperbolas, these open up and down. This is a y minus k squared over a squared minus x minus h squared over b squared equals 1. And again, a is first. So whichever variable comes first, whichever variable is positive, that determines which way your hyperbola goes. Everything after that, well, not everything, but most things after that are similar or the same as an ellipse. A is still center to the vertices. B, center to covertices. It's catching up. Yeah. C, center to foci. The A and C exist on what was called the major axis. It's now called a transverse axis, but it is the same concept as the major axis. And the foci occur on what is called the conjugate axis, which is formerly known as minor axis. Transverse is 2A. Conjugate is 2B. And another major difference is c squared equals a squared plus b squared for your hyperbolas. So remember, it's the opposite sign of your standard equation. Your standard formula for ellipse has a plus in it, and the c squared is equal to a squared minus b squared. Your standard equation for the hyperbola has a minus in it, and it is c squared equals a squared plus b squared. And then the last thing is your asymptotes, which is actually, that's where we pick up, which is here. All right, so these... All right, so asymptotes are those lines that crisscross to make your hyperbolas as narrow or wide as they're supposed to be. Each hyperbola has two asymptotes. They intersect at the center. The asymptotes pass through the corners of a rectangle of dimensions 2a by 2b. So if you remember this from Algebra 2, you find your center. In this example, this is a horizontal hyperbola. So I go right and left A. They went right and left A. They went up and down B, and then they made a box that crosses through it. It could be a square because A and B can actually be the same. If most of the time it's a rectangle. And then that's what determines how wide to make your branches. So this was horizontal. They put the vertices on wherever the A was from the center, and then they made this as wide without touching those asymptotes as possible. So if you are just drawing your hyperbola, you don't need the equations. You can make the box, find the corners, and cross it through. But then there's going to be times in which it will ask you for the equations, so you can use the equations to graph those lines. I would recommend the box. I think it's easier, but you can do both. And here's how you find the equations. So there are two equations, one difference, and that's it. And that is, it is b over a or a over b, depending on if it is horizontal or if it's vertical. So if it's a horizontal hyperbola, then it's y equals k plus and minus, because there's two of them, b over a times x minus h. And if it is vertical, then it is y equals k plus and minus a over b times x minus h. So the only difference is the slope. For horizontal, it's b over a. For vertical, it's a over b. Okay, so notice that these are in kind of like a modified point slope. You can leave them like that. So if I ask you to give me the asymptotes of the hyperbola, You don't have to distribute that out. Sometimes you will get given the asymptotes and they will be in either format. So if you wanted to distribute it out because you're comfortable graphing lines that are in slope-intercept form, feel free. If not, I would use the box. Like, I just think it's easier. All right, so example 2 says sketch the hyperbola whose equation is 4x squared minus y squared equals 16. So what's the first thing you got to do here? Divide by 16. It's got to be in standard form. To be in standard form, it's got to be equal to 1. So I get x squared over 4 minus y squared over 16 equals 1. And now I'm in standard form. Now tell me what you know about this guy. It's horizontal because x is first. What else? Center is 0, 0 because there's nothing after the x or the y. What else? Good. A squared is 4, so A is 2. And? Good. B squared is 16, so B is 4. I don't need the foci to graph it. If it asks for it, we're going to find that in a minute, but on the next question. But I don't need it. So basically, as soon as you get the 0, as long as you get the center, the A, the B, you've got everything you need to graph. So I'm going to pull in a graph, and I'm going to plot this sucker. So I go 0, 0, that's my center. Horizontal means go right and left the A. So right 2 and left 2, give me my vertices. That was a change in x, negative 2, 0, and 2, 0. Then I go up and down the B, which is 4. Some of those are my co-vertices, which would be 0, 4, and 0, negative 4. And now you can make your little rectangle. So I want to make a little box that passes through those 4. I want to identify the corners of those boxes, or that box. And I want to pass my asymptotes through it. So this is easier to do on Notability because you can do the straight dashed line, but it would look something like this. If it was vertical, I'd have them go up and down. This one's horizontal, so they are going to point right and left, and I'm going to make them as wide as I can without touching the asymptotes. Doesn't have to be perfect, but it should be pretty wide. Now, because c squared will be a squared plus b squared, the foci will always fall inside the scoop. So it would always be bigger than A. Again, we're going to find it on the next one. But it would always be bigger than A if I needed to graph the foci. I don't need the foci to graph. But if it had asked for it, which your test is going to give you like questions like that where it's multi-part, where you have to find the center, the vertices, the co-vertices, the foci, and you'll have to find the asymptotes. So we'll review that real quick. But this one didn't ask for it. That right there is enough to graph. Now let's say it had said find the asymptotes. Because this is horizontal, it's a B over A. If it was vertical, it's A over B. If it's horizontal, it's B over A. So this would be Y equals K plus and minus B over A X minus H for the asymptotes. Y would equal, my K is 0, plus and minus, B is 4, A is 2, X minus, my H is also 0. And then I would just simplify that. And those are your asymptotes, 2 of them. One is a line with, well, they're both lines, with a y-intercepted 0, 0. One would have a slope of positive 2, and one would have a slope of negative 2. So if you look at your graph, if you start at 0, 0, you go up to the right 1, there's one asymptote. You go down 2 into the right 1, and there's your other asymptote. Questions? All right. Now I get put the equation in standard form, then find the asymptotes, then sketch the hyperbola given by the equation. What do you got to do with this guy? I got to complete the square. Start it. Yay. You only got... All right, you can keep going, but I'm going to get us started. So I'm going to group together the 4x squared plus 8x, then the minus 3y squared, and then I'm going to bump the 16 to the other side, so it's negative 16. Let's say there was a y in this too. Make sure you pay attention that that negative would be on the negative 3, so it goes with it. So if there was another y here, when I take off the negative 3, it affects the y as well. So this is where you got to watch your signs. This time there wasn't another y, so I only have to complete the square on the x. So I take out the 4, I get x squared plus 2x, leave my space, minus 3y squared equals negative 16. Then I do the 2. 2 divided by 2 is 1. 1 squared is 1. I'm going to add the 1 inside, and then I'm going to add it to the other side, but not forget to multiply by the 4 that's on front, which means I'm actually adding 4. Now I've got 4. Square root the first term, square root the last term. Take the sign from the middle, put it in parentheses, and square it. Minus 3y squared equals negative 12. And then to get in the last, into standard form, that last step is what? Good. When you divide by negative 12, what happens to your signs? They switch. So this becomes 3. This becomes 4, but this becomes positive, and now my negative's on the first one. So I want to switch them. I want to do y squared over 4 minus x plus 1 squared over 3 equals 1. So you'll never leave the negative in the bottom. You'll pull it up. Which is also why we would never look from the beginning and say, is this a vertical or horizontal hyperbola? Not until you get it into standard form. Because if I look from the beginning, it's x squared minus y squared. We would have said that that is a horizontal hyperbola, when in fact, once I get it into standard form, it's y squared minus x squared, which means this is a vertical hyperbola. All right, so tell me what else we know about this. Good. Center's negative 1, 0. Xavier, what'd you say? Good. A squared is 4, so A is 2. B squared is 3, so B is the square root of 3. Now, when I'm using that to get my covertices, like if the line says, give me the covertices, or if website says, give me the covertices, I'm going to keep that as square root of 3, so it stays exact. But when I go to graph this, I'm going to approximate that. Remember, we said square root of 3 is like 1.7, 1.8. So you're gonna approximate that. But now we got to find all the other stuff, okay? So it says sketch the hyperbola, which means I'm going to pull in the graph. And I'm going to start with already what I've got. I've got my center at negative 1, 0. It's vertical, so I'm counting up and down the A. Up 2 and down 2 gives me vertices at negative 1, 2 and negative 1, negative 2. Right and left square root 3, we're going to approximate to be like a 1.7. So I'm going to go to the right and to the left for my graph. But when I write it, my covertices, I'm going to keep it as square root 3. I'm changing the x. So negative 1 plus and minus square root 3, comma 0. Would be my covertices. From my graph, I can make my little box. Find the corners. Draw the asymptotes. And it's vertical, so this is going to point up and down. Now, when you do this on homework on WebAssign, you have to hand draw these. Some of the questions are multiple choice. Obviously, you can hand draw to the point of getting it there. But when it comes to your test, this is not multiple choice. You're going to have to graph these by hand. And when you don't practice it, I get some really weird shapes. So make sure you know how to draw these things. Okay, now I'm going to find the foci just because we haven't yet. So I'm going to find the foci in addition to the vertices. So my c squared equals a squared plus b squared for for a hyperbola. C squared would equal, my A squared was 4, my B squared is 3. So C squared equals 7, and C is square root 7. Now, if I was to graph that, I would assume it falls within the scoop, so I would make sure. Obviously, square root 7 is not a perfect square, but it's in between root 4 and root 3, so it would be in between 2 and 3. So let's say I go a little past 2, I'd be inside the scoop, and down a little past 2, I'm still inside the scoop, which confirms it. To write those out, though, I changed the y. So my x stays the same, and the y, which is 0, gets a plus and minus square root 7. So I end up with -1 plus and minus root 7. Yep. So figure out what two perfect squares it's between. 7 would be in between 4 and 9. Literally split the difference. It doesn't even matter when you're graphing. You're not going to be that exact. But in between root 4, which would be 2, and root 9, which would be 3, is where you want to be. And then it asks for the asymptotes here. So is this an A over B or over B over A? Nope. A over B. Why? Vertical. Vertical is A over B. So y equals k plus and minus a over b x minus h. Y would equal my k, which is 0, plus and minus. My a is 2. My b is square root 3. X minus a -1 becomes x plus 1. You cannot leave that root in the denominator, so the last thing we're going to do is rationalize. I get y equals, the 0 goes away, plus and minus 2 root 3 over 3 times x plus 1. And there's my asymptotes, and then my vertices, my covertices, and my foci. So with hyperbolas, you find one more thing than you find with ellipse, because you have to find that asymptotes. So these questions, I forget how many are on your test. I'll look at it again. I think it's like 16. These questions are going to have multiple parts. They're going to be worth more than something that just says, here's the, or find the equation. Yeah. X minus a -1, so it becomes x plus 1. We still good? Yeah? The good news is I think after this it gets a little bit easier. All right, so now we're finding the standard form. So we're working backwards. It says find the standard form of the equation of the hyperbola having vertices 3, -5, and 3, 1, having asymptotes y equals 2x minus 8 and y equals -2x plus 4. So as I do with all the parabolas and all the ellipses, I plot the information that they give me to see if I can get the visual of the understanding instead of trying to figure out in your head. I'd strongly recommend the same. So if I have a vertice at -3, 5, I'm sorry, 3, -5, and 3, 1, what does that tell you about this hyperbola? It's vertical. If it's vertical, which letter comes first? Y. It's y squared minus x squared. What else can you tell me from this, or what else can you find from this? The center is not at 0, 0 this time, right? If you like graph it with like actually doing those accurate spacings, you could find it visually or count it out. If not, remember you're finding the midpoint given those two. Whether you're given the two vertices, covertices, or foci, the midpoint is the center of any of those. So I would do 3 plus 3 over 2, or -5 plus 1 over 2, 6 over 2, which is 3. And -4 over 2, which is -2. 3, -2, makes sense. Visually, too. That's your center. And then what value or what letter is your center to your vertices? A. So if I'm going from -2 to -5, or -2 to +1, A is what? 3. Now I've got all my numerators because I've got y minus a -2 becomes +2 squared over my a squared, which is 9, minus x minus 3. squared over, I got to fill that in, but it equals 1. All of that gives me every little thing except for b. So even if I had no idea where to go from there, you could earn some partial credit just from using your vertices. Okay, now second piece of information it gives you is your asymptotes. But notice these are in slope-intercept form, right? It was already distributed and combined like terms. The most important thing when you are given your asymptotes for your A's and your B's is your slope. So if I look at the slope here, they should be the same. One should be positive, one should be negative, which is the case. So I'm going to either set that equal to A over B or B over A. Which one? A over B, because this is vertical. So 2 equals A over B, or negative 2 equals A over B. It doesn't matter. And we know A is 3. So 2 equals 3 over B, which means 2B equals 3 and B equals 3 halves. So when I put it into the equation, what do I do with B? Square it. What would be 3 halves squared? 9/4. And WebAssign will allow you to keep it like that. Like literally the denominator is a fraction, and that's okay. If you were to see this on a standardized test or like a question that had a multiple choice, they will keep, change, flip this and bring this to the top. So they would rewrite it as y plus 2 squared over 9 minus 4x minus 3 squared over 9 equals 1. This would be a multiple choice answer, which is not happening on your test. You're getting it open-ended. That will work. Yeah.
So how do you get 2 equals A over B?
Because if you look at your asymptotes, the slope is what you want to pull from them. It's going to be positive and negative, so I always take them positive. It wouldn't matter because you're going to square it no matter what for the B. But you just grab that slope and figure out, is it A over B equals that, or is it B over A equals that? Yep. Questions on that one? So obviously, like the ellipses and the parabolas, they could give you a number of different types of information and ask you to find the hyperbola. You could get the vertices, the covertices, the foci, the asymptotes, the transverse axis, the conjugate axis, like all of that information can get given to you, but it will be enough information to give you either the A and the B, or the A and the C, or the B and the C, and then you'd have to find the A using C squared equals A squared plus B squared, okay? So a lot like what we did with the ellipse. Questions? Okay, so eccentricity, just like with an ellipse, is C over A, exactly the same formula. And instead of determining how round it is, it's how wide the branches are. The bigger the E, the wider the branch, okay? So if I have a really big E, and it's going to be bigger than 0, instead of where the ellipse has to be between 0 and 1, your hyperbola has to be bigger than 1 because C is always going to be bigger than A. This will just determine how narrow or wide it is. And classification is the last thing we're going to talk about. So if I have an equation and it's in general form, so general form means it's expanded out. It is not in parentheses squared. So you will have an x squared and an x, a y squared and a y, okay? They are not in standard form. It is not equal to 1. If it's in this form and it asks you to classify it as a circle, parabola, ellipse, or hyperbola, you would not want to have to put it all the way into standard form. Like I wouldn't want to have to complete the square to figure out what this is. So this is your like shortcut. So A is what's in front of the x squared term and C is what's in front of the y squared term. You can ignore everything else. If A equals C, it's a circle. If you think about it, they'd have the same same coefficient. So if I divide by it, it's going to go away. If A equals C equals 0, then it's a parabola. That means one of them doesn't exist. You don't have a y squared or you don't have an x squared. To me, you don't even need the A times C equals 0. Look at your equation. Do you only have 1 squared? Because then it's a parabola. If A times C is positive, so it's bigger than 0, that means they're going to be both positive or both negative. That's an ellipse. And if A times C is negative or less than 0, then it's a hyperbola. So if one's positive, one's negative, it's hyperbola. Again, these are questions that should take you 10 seconds. You don't want to have to be putting them into standard form to figure it out then. You should be able to look at it and figure it out. So classify the graph of each equation. Look at A.
Oh, that's the first one. A circle.
What's your A squared? 4. What's your C squared?
There's none.
It doesn't exist. What happens if one doesn't exist? It's a parabola. The first one is they're the same.
Oh, we have to equal each other.
Yeah. All right, go to B. There is both, so it's not a parabola. A is 4. C is -1. What happens if I multiply those together? What kind of number is it? It's a negative, which would mean hyperbola.
We just did it.
C. A is what? A is 2. Good. And C is 4. Multiply those together. It's positive. That's an ellipse.
Do the circle.
Good job. Last one. A and C are the same. That's a circle. Say again?
Can you go back to the
Yes. Questions on those?